Hi everyone and welcome to this video. In this video we are going to use various um, linear models to address different questions that we may have, and more specifically we are going to discuss how to analyze interventions. So when we analyze interventions with experimental designs, we are often faced with multiple sources of variation all at once. And notably, it is frequent to have repeated measures. For example, we could have a pre-test, a post-test, maybe follow-ups. Um, Group predictors, and usually we would have a control group and an experimental group or treatment group. Perhaps we have 2 or 3 treatment groups. Perhaps we have a placebo group, etc. And also, we sometimes have numeric covariates. Yeah, in our design. For example, we want to control for age, let's say. So these create situations that can be particularly challenging from a statistical point of view, and also these create situations where we can have multiple hypotheses to test. And so we're going to talk here about how to address common hypotheses within such contexts. And so this is structured around a number of hypotheses. And for each of these hypotheses, we're going to try to find a test that addresses the hypothesis within the framework of linear modeling. So this will actually be, in most cases, sorry, an F test. Even though sometimes they will be equivalent to, for example, a T test. So our objective will be primarily to find that relevant F test that actually tests the hypothesis that we want to test. And also we are going to try to find a way to represent the effect in a plot. These are 2 objectives for each of these hypotheses. So we're going to start with hypothesis 1. BDI levels at 2 weeks are lower in the intervention group than in the control group. So if we look at our data set over here, we have a series of variables. Let me extend that a little bit. So we have here an ID variable. Very interesting here. Obviously, these are just incremental with just these are just case names. We have here first level of BDI. So we have 4 repetitions. We have a baseline. We have BDI at 1 week, 2 weeks, 3 weeks. And here we have different groups. So I'm going to look at this group variable in a second. And we also have a covariate, which is openness. And all of that is really described over here. So first off, in this hypothesis here, we're only studying BDI levels at 2 weeks. This means that we are going to study this outcome variable, not the other ones over here. So in other words, we're not really in a repeated measures design yet. So we're only going to focus on this one. And we want to compare between 2 groups. So we want to compare BDI at 2 weeks between 2 groups, between the intervention group and the control group. So here, if we look at the group variable, let me double click on it. Look at this group variable. We will actually see, especially if we click here, we'll see that it has not 2, but 3 groups. Right, we have 3 groups: control, intervention, and placebo. Control is 1, intervention is 2, placebo is 3. At least that's how it's coded in the dataset. Here, however, the hypothesis asks us to compare 2 of these 3 groups. So there's actually a number of ways in which we can address that. But one of the ways which we are familiar with would be to use the independent samples t-test in SPSS. I'm going to do that very quickly because probably very familiar with this already. If we click on Analyze, Compare Means, independent samples t-test, we'll we'll select BDI at 2 weeks because that's what the hypothesis is about. And we want to compare groups. And we want to compare intervention and control, which are here groups 1 and 2. We're going to click on define groups, and then we're going to keep 1 and 2 here, which actually are the default. So we're going to compare group 1 and group 2. All other groups, so here there's only one other group, which is group 3, will be ignored. So I'm going to click on continue. Okay. And so I'm going to assume equal variances here. The first line is student C-test, and we have the two-sided p-value, which is here at 0.004. So this could be a way to address that, but more generally here, let's say that we want to keep this framework of general linear modeling, of which this t-test is actually a particular case of. There are some things that are missing in here also that could motivate us to look for something else. Notably, we don't have a plot to show the differences in means with confidence intervals. So how could we address that within the general linear modeling menu? Well, the problem is if we use the general linear modeling menu, right here, analyze general linear model, univariate. If we did that, we would here use the group directly, but here we would actually use group in its full nominal level, right? In other words, with all the three categories. That's not what we want to discuss here, because that's not what the instruction is about. The instruction is really about these two groups that we want to compare. So we want to ignore the placebo group. So the way we can actually do that is we can, I'm going to cancel this analysis here, and I'm actually going to filter my data set so that I will filter out, the placebo group, which is coded 3. So what I'm going to do is click on data, select cases, and then I'm going to select cases if condition is satisfied. So here, click on if. So here I'm writing my conditions to select cases. So I want group 1 and group 2. I don't want group 3. So I could do something like this, group, I can double click on that, group equal 1, or group equal 2. This implies that I will only keep groups, I will only keep cases for which group is equal to 1 or group is equal to 2. In other words, I will exclude group 3. I'm going to click on continue, and I'm going to keep this filter out unselected cases. There are different methods in which we can do that. Could create a new data set with the selected cases only, or delete the unselected cases, but I might want to reuse them afterwards. So I'm just going to filter them out of analysis. And so I'm just going to click OK. When I do that, you'll actually see in the data set it's created a new variable, which is called filter. And it essentially tells me which cases are selected. So here actually see, so it only shows me the selected cases. I see that actually I only have control and intervention as main groups. And the way you could verify that, by the way, if you don't want to scroll through, because here it's manageable, of course, to scroll through, to don't have any cases. But if you right click here, click on descriptive statistics, you can check. It should only show you control and intervention because the rest are excluded. So here we only have control and intervention. So we made sure of that. Now what we're going to do is we're actually going to use the general linear model menu. So I'm going to click on Analyze, General Linear Model, Univariate. And so I'm going to select as my outcome variable, dependent variable, BDI at 2 weeks. And I'm going to choose as my fixed factor the group. So that's it for the specifying the model itself. What we can do is we can notably get a plot. So if we click on plots, what we'll be able to do is show the dependent variable is a function of the group. The group will be on the horizontal axis. To add that to my list of plots, I'm going to keep a line chart, and I'm going to include error bars with confidence intervals. Click on continue. I can also get the estimated marginal means of the model, because these are the means as implied by the model. I'm going to click there. Just going to select the mean by group. Since there are only two groups, really unnecessary to compare them. But if we had more than two groups, it might be useful to have pairwise comparisons. I'm going to click on continue. And one thing I can also do is in the options, I can also get estimates of effect size. So let's look at the output now. Very readable. Okay, so we have our plot with control and intervention. It seems like in the intervention group, we have lower levels, as actually we had seen with the t-test. And so here we actually see the effect of the group with the F value over here, degrees of freedom 178. This is the p-value 0.004. We should not be surprised by this p-value. It's actually the same. You can check that, but it's actually exactly the same right here as the one we actually originally had in a two-sided students t-test over here. But now we have more output. Essentially, we have the estimated marginal means over here with confidence intervals, which are also represented in this fairly publishable plot. Okay, so that's it for question one, or hypothesis one, I should say. So now hypothesis two. BDI levels at 2 weeks, so far it's the same thing, same outcome variable, are lower in the intervention group than in the control group. So that's really the same. It's the same here as before. The new thing is we want to control for openness. So it's fairly easy. We are still focusing on the same two groups, so we don't need to refilter anything. It's already been filtered for the first hypothesis. But now we won't be able to use a t-test first. But now the new thing is we want to control for openness. So in other words, here we will want to use, instead of a one-way ANOVA, which is what we just used, which was also, in fact, an independent samples t-test, we will now use a one-way ANCOVA because we will control for openness levels. So the way to do that is to, again, use the analyze, analyze general linear model univariate menu. So we're going to use the same structure here with BDI at 2 weeks as our outcome variable, the group, which, as we remember, has been filtered already. And we will keep, we'll use, openness as a covariate over here. Let's look at what we can get from here. We click on plots. We are going to keep the same plot as before with a group as the horizontal axis and a line chart with error bars. So nothing to change here from what we've just done, except that now we are going to have estimated marginal means that account for openness levels. Same thing for estimated marginal means. We can display means by group. Now these will be different than the ones we previously had, because again, now we are controlling for openness. And same thing in the options, we might want to keep this, the estimates of effect size for the effects we're testing. And so here we are studying the effect of group. So even though we are controlling for openness, we're interested in the effect of the group controlling for openness. So this is the effect we're going to be studying here still. I'm going to click on OK. Same thing, if we look at the estimated marginal means as a representation of the model, we actually see fairly similar findings. It looks like the intervention group has lower levels BDI after 2 weeks than the control group controlling for openness. And so it's confirmed in the test over here. If we look at the effect of the group, again, we control for openness, but openness we're not really interested in here. So we only want to control for it. So here we see an effect of group with a p-value of 0.005. So this is F statistic, degrees of freedom 1/77. F statistic, and here the p-value 0.005. So here we have a significant difference between the two. So BDI levels at 2 weeks are significantly lower in the intervention group than the control group, controlling for openness. And also we've seen previously not controlling for openness as well.